So today, what we're going to talk about is how to go about modernizing your Hadoop infrastructure. We're going to go through some of the things that we've seen or heard from our customer base, and some of the ways that they were able to modernize or get better performance out of what they already have, and have a path to migrate off if they wish to do so. And yeah, my name is Wei. I'm a solutions architect here at Starburst. So just a little history on how we got started. Um, there was a team of 4 developers at Facebook who was really struggling to get performance out of their Cloudera Hadoop environment. And then, the challenges I can go into later. And then, but what they were able to do was they were able to build a from the ground up query engine that's dedicated to querying the data lake. So it doesn't have any ties to any vendors. It's just a standalone platform. And the ease of use, ease of scaling is really what allowed them to extract a lot better performance and concurrency and scale. And then moving on, they decided that this technology is really great. They wanted to share it with the world. And then they went on to open source, develop the Presto open source project. However, Facebook, came in and said, well, this was developed here. We want to keep the name Presto. So they rebranded to Trino, which is the open source project that we maintain today at Starburst. So Starburst is really brings you the enterprise capability. So all the nice features like RBAC, Helm charts, and some additional layers like data products, which we'll go into later too. And something called warp speed, which is really interesting. Well, so Trino has seen a lot of development over the years, and just really allowed all the companies you see on the bottom to really extract the most out of the data and just run the data at just these massive internet scales. And then Netflix comes along and open sources a new table format called Iceberg. Traditionally, as many of you know, that queries on a data lake can be great, but anything if you wanted to have as a compliance, fast DML queries, the traditional data lake formats are not going to. You basically have to rewrite the entire file. And then Netflix basically says, well, I get great performance out of Trino. Why not create a table format and take advantage of all this performance gain and the ability to scale. So brings us to today, actually. So Trino and Iceberg combined, we deliver a lot of value to, again, these major internet companies. And we're seeing Iceberg is just top of mind for almost every major enterprise that's out there. You'll see competitors like Databricks. They have their own Delta Lake format, but they acquired a company called Tabular recently, which only manages Iceberg tables. And Snowflake is getting into the game as well when they open sourced the Polaris catalog. So why does Hadoop struggle right now with the amount of demands of data? Well, when the Hadoop environment was created, they were kind of dealing with the challenges that they had at that day. So hardware failures was very common. So the way they decided to work around that is to replicate data, data by 3x. So when one of their nodes fails, they can still continue to run the query to get the data that they need. The computer is tied to storage. Well, network bandwidth wasn't as robust or good as it is today. So the compute blocks always sat on top of the storage blocks, and then that's the way that they were able to get again decent performance out of the lake. Today, we're seeing that a lot of companies use erasure coding, which has a lot smaller footprint than the 3S replication. And then because of we're overcome the network latency challenges that they had at the day, we're basically to decouple the compute from the storage and have a standalone engine. And then really because of these limitations, the Hadoop environment really today suffers under concurrency. If they add more users, the queries would slow down by a lot. So a lot of organizations try to protect that environment as much as possible. And then usually the way they do that is to copy the data forward to a data warehouse where the data can be served. So that creates some complexities and another copy of data. And I'll show you how at Starburst we solve for some of these challenges. Limited query optimization, the Impala engine really hasn't changed much ever since back in the days of Facebook. Their open source project really isn't seeing as many commits and interaction as the Trino project that we maintain here. And yeah, the code base is pretty stagnant, and then there's really not a way to federate to other data sources if they need to. So what they leads to is failing cost model. Again, triple replication just causes the infrastructure sprawl to become huge and unmanageable, failing performance, and really not enough innovation on the Impala engine. So this is just a visualization to see what the HDFS infrastructure looks like. Again, everything is triple replicated. The blocks are spread out in a way that if one of these data nodes fails, you can still continue to operate because you have replicated your data by 3x. And then the compute nodes sit on top of each of these data nodes. And then if you grow your storage or you grow your compute, then you will get an excess of computer storage that you probably didn't need. So how the Starburst architecture works, again, we are a standalone system. We are just one single coordinator that comes up with the best cost-based optimized way to run the query. And that happens in a split second very quickly. And then when the plan is complete, that gets assigned to all the worker nodes, and then they bring all the data back in parallel. The tasks are assigned to all the workers, and then it's not a sequential format, so it's massively parallelized. So all the data gets brought back and very performantly gets back to the coordinator. Coordinator aggregates all the data and sends the results off to the user. And then if you take a look at the upper left-hand corner here, if you have HMS in your Hadoop environment, we can utilize that Hadoop environment as storage. So we don't have to rely on the compute engine for the Hadoop environment. So you can still continue to run your Impala and Hive jobs as you're doing today without any disruption. So a look at the new open data lakehouse is what we call it at Starburst, and what the architecture looks like. You have your open file formats, the common file formats that gives you great query performance on these data lake formats. And then Iceberg and Delta Lake comes along and said, we're going to give the ASIL compliance and fast DML queries. And how they really do that is they were able to just create snapshots of new writes. And then when they read the schema or read, you give all the results back to the user. And then the other neat features like time travel. So now you can see, if you go back in time to see what your data looks at a particular moment in time, you have the ability to do that as well. And then you have compaction to make the data files in larger chunks so you don't have a small file problem. And then Starburst sits on top of all of this. You can query open file formats, open table formats, as well as these other data sources up top. We have the Snowflakes, MongoDBs, Google BigQueries, and 50 plus enterprise level connectors. So what that really means is a lot less data movement. Everything can be queried on the fly using one SQL statement. And really what that results in is what we're seeing is just 90% faster time to insights, less moving around the data, lower TCO because you don't have to move data around and keep different copies and have different environments where you need to share the data. Everything can be shared using one environment because of our engine's ability to scale really easily. And then you can future-proof your architecture. If there's any developments in Iceberg, or if there's any new formats that come along that does a better job, you are free to move to it. You have the ultimate. You're really flexible to choose whatever platform or file that you need from here. So going into what we think the North Star Lakehouse architecture is. Like I stated earlier, in previous versions of the data lake, for example, like Cloudera, to overcome some of the challenges with performance and data sharing and concurrency, the really solution that they came up with was to copy forward into a data warehouse where it can be shared. But if you overcome this idea that these constraints with resource contention and concurrency and add compute as needed, then you can really serve your land, establish your land structure, consume environments, zones in the same environment, and then you can serve data directly from the data lake. So you have your raw semi-structured data alongside your analytical data that is ready to be consumed. And the control plane for Starburst has a lot of really neat acceleration features, like something like warp speed. Warp speed is autonomous indexing and caching for commonly run queries. So it actually caches a lot of the commonly run queries on locally attached SSDs. So you don't have to reach out the network or underlying storage. It comes directly from the worker nodes because it knows what the most common queries are being run, and it can cache that ahead of time. Auto scaling and idle shutdown. So in Galaxy, we have this feature where if we see that data demands are increasing, then we can automatically scale out your compute nodes to be able to really meet that access demand at that time. So so your queries won't just slow down to a halt or not run at all. So there's a less likely that you're going to run into that problem. And then if you want to run in fault tolerant mode for these long running batch jobs, you can do so as well. So we give you a lot of flexibility to pick and choose between all these. And then we add a lot of features that built into our platform, like RBAC, ABAC for row level filtering and column masking. And then you also have data lineage and data quality and query history and auditing tools as well. And then there's also data products and data sharings that we have built into the system. So on the right, you can see you can serve now all your data science and BI related time system analytics all on the same platform. And a closer look into all the features that are built in terms of data access, security, what the query engine is able to do, and really what you get at the modern layer. So we talked about, we went into a little about data products and data lineage. You can, there is the ability to create materialized views and global search as well, which is very neat. For the query engine, again, warp speed, I'll call out here. And for security, we have end-to-end data encryption if you want it. SSO, we can integrate with LDAP. So everything that an enterprise needs is to make sure they have the best security governance. We can offer that. In terms of data access, we have data source connectors to, again, 50 plus enterprise-ready connectors. And Stargate. Stargate is a really unique Starburst feature that allows you to join your on-prem and in-cloud environments or even cross-cloud. So the idea is that if you have multiple clusters deployed in different localities, you can push down the processing to those different localities, and you only bring back the data that you need. So what that means is you get efficiency, you get better performance, and then most of all, you get charge less egress. And on top of that, it's just managing security governance becomes very simple as well. You're able to see all the catalogs, no matter which regions, and you can apply different policies depending on which region the data is coming from. So GDPR, data sovereignty rules, a lot of companies were able to solve these challenges easily using Starburst as their platform. So how Starburst helps. So just a little overview of what the data journey will look like. So first we would really enhance your current environment that you already have with very little disruption just by bringing Starburst. So you take a look at what time sensitive jobs that you have that are not running performing today, and only maybe move those over to Starburst and just get value right away. Because we're a standalone engine, we really are as performant on Hadoop as new object store environments. And then you can say, and then there is a feature from Dell that we partner with that makes this whole solution turnkey. And then Dell actually has a tie-in with their own object storage, so a complete infrastructure offering that can really give you kind of a lakehouse infrastructure on-prem. So a lot of these ease of scaling and turnkey that you see with the SaaS offerings in the hyperscalers, you can get that on-prem with this offering as well. And then you can really adopt a cloud migration strategy as well. Using something like Stargate, you can basically choose and pick which things you want to move first, and then you can have the connectors to connect everything together and really continue to operate your business while migrating is happening in the background without this lift and shift and waiting to see what happens. And then really going beyond the data warehouse, again, these analytical zones can be established now on one platform instead of copying to different places. So you're reducing multiple copies, you're simplifying your infrastructure, and you're also making sure that really where your data is created and your data is consumed is in one spot. We think that just makes the most sense for data quality. And then just operating in a sustainable future model where you can pick and choose really where your data is. We really meet your data where your data resides. And if there's any new data platforms, you can feel free to choose it really. And then if there's any new innovations that come along, you can take advantage of that really easily as well. So yeah, some of the things that you get out of Lakehouse, a lot better TCO. We've seen upwards of 10x, and we've seen more actually if you really factor in concurrency, better access and faster SQL. And then better access to data just means that you have a system of connectors now that you can really reach out to all your data and combine it if needed. If not needed, you get great performance on the data lake. Again, in the lakehouse architecture, we give you that warehouse performance already. And then 5 more access also means that instead of copying your data 5 times, you can just keep one copy of that data and using something like our RBAC rules to be able to manage the sharing of that data. So what the modernization journey looks like, this is kind of repetitive again. You can start splitting your compute and storage. This is something that really Starburst is one of the platforms that allows you to do that, is that you can augment what you already have today without really ripping and replacing. And then you can monitor your storage because we actually give you really good performance on HDFS and new object storage. And then we can do that by federating between the two. So because that performance is so good, the users of that data really wouldn't really know or care where that data is coming from. They still are getting great performance. And then for data engineers and data teams, what that means is you can now do the migration on your own terms. You don't have to do this lift and shift. You can basically pick and choose the data that you need, whichever data is in terms of your data needs and the most time sensitive, the ones that require the most security. You can really have control over your own data, your own migration journey using Starburst as the engine. And then, yes, we can help you with your multi-cloud hybrid environment as well. So just some comparisons, really, of the different technologies that Hadoop employs today. Over, we can provide a Starburst. Hive is kind of the original query engine, but it has a lot of administrative overhead, and if you scale it out, it's really it's going to be really difficult. It's going to be very complex to deal with, and it doesn't really handle scaling. It's not really meant for that. And then it doesn't really give you that fast query analytics that sometimes that a business really needs. So at Starburst, basically, we solve for all the challenges by having a low latency MPP engine that can federate between your old and new platforms. And then some of the complexities that are seen today with MapReduce and all this resource managers, we have done away with all that. Starburst, again, the infrastructure that I had showed earlier is just one coordinator that governs a large number of workers, and then that workers can grow to support very high concurrency. So that is, the simplicity and of the platform is just when you are needing to scale, it becomes very easy. And then if you want to reach out to the other data sources, we can do that with the additional connectors. Hive, really, there's only 10 open source projects that they're able to federate to. Impala is actually, it's actually a great query engine. The only time that Impala runs into trouble is you have concurrency that we see of over 15. And then if you want to really tune or rescale or really retune Impala, we've seen it being very, very complex as well. Is really the first MPP query engine. For its day, it was definitely great. But what we see with Trino is if you do a head-to-head comparison, because of this cost-based optimizer, the way it's very efficient at getting the data back. We can give you the better performance and the under concurrency because we're not bringing a whole ton of data. We can take advantage of the partitioning of whatever stats we can collect on the data lake on the tables. We only bring back really the data that's really needed for the query alone. And then we actually support our own built-in security solution. We can incorporate with Apache Ranger if you already are using it. But if you want to migrate to a more modern solution or third-party vendor, we have actually very close partnerships with something like Sarah and also Immuta as well. So really, just to look at the complexity of running the Impala, right, engine. Again, it's if you want to retune it, it becomes the whole environment becomes pretty complex. So with Starburst, basically, just again, we can just replace all of that with a easy to use architecture, easy to scale out, and then now you have security, governance, semantic layers, and data federation all built into the same platform. Just some comparisons. So again, Hive has connectivity to some of these other platforms, but Impala doesn't. And the Starburst really gives you the best of both. It's an MPP query engine that could connect to 50 more than 50 enterprise data sources, and it gives you the ability to run your query on a high concurrency and really good performance as well. So you can kind of run your interactive batch ad hoc queries, all using the same platform. You don't have to choose all these different other tools. So if your data needs to stay on-prem, I just want to go into a solution that we have partnered with Dell. We work very closely on this turnkey solution. So if you want to modernize your data environment on premises, there is a turnkey solution. It's self-contained Kubernetes, and all these complexities of managing Helm charts, making sure you have the correct Java version, all of that is abstracted away, and then you can get up and running just by racking it and connecting it into your network, and it's ready to go. All the networking for the environment is actually self-contained. And then if you want to do data federation to your HDFS environment on the left side, you have a way now to really migrate at your own pace. And then if you want to bring back data from the cloud, you can do that as well. So your data gravity is still on premises. This is a great way to do it. And then if you want to start these small sandbox projects in the cloud, or where some cloud native applications or some data that gets generated in the cloud, you have the ability to really get the best of both environments. Again, our data locality with our federation capabilities it means that you can apply RBAC no matter where the data sits. So yeah, Dell Data Lakehouse, as I go through the demo, you're going to see basically the environment looks exactly the same. So whatever demo I will show you, Dell basically, it just comes in the Dell color scheme. And on the lower left-hand corner, this is just a little reminder that is powered by Starburst. And then on premises, it works exactly the same way. It's highly concurrent MPP query engine that has a very cost-based optimizer, efficient, that could assign tasks to workers and bring back everything in parallel. There's no waiting for tasks to finish before the next task needs to be kicked off. They can all happen at the same time. So again, easy to scale. You have decoupled your really query environment from your data environment. So if you want to use a different vendor, let's say, for your storage, you have the freedom to do that as well. And then if you want to federate between the two, of course, we offer that capability. And then, yeah, on the concurrency especially, we can get more than 10x of performance than Hive and Impala. So, and then as Starburst, we actually have we've done this time and again. So, it just makes sense that Hadoop replacements are one of the projects that we are the most familiar with, really. When I first started, going on this topic earlier, you can see that really from day one, we were meant to augment the Hadoop environment. And then from there, we were really able to build our own separate platform. And then offer some of these new scaling and performance and overcome some of the challenges that we see organizations having. And then we do have a professional services team that have a lot of expertise in doing this. So they can really help you with staff augmentation or just guide you along the way if need be. So just to recap, the best practices, you can replace your Hive and Impala engine. You can really just target high priority use cases first. This just immediately alleviates any resource constraints that you're having, and then you really are only moving your workloads in chunks. You don't have to migrate everything at the same time. You can still get the great benefits of the Starburst engine without replacing your current environment. And then really just assessment of your data, just where are the relationships and dependencies. You can choose for yourself, is a mono storage needed? Is there a desire to move into the cloud? And how much do you want to move? And then how much data is being generated, whether on premises and in the cloud? Do you want to work in hybrid mode? You can really analyze this, and you have the flexibility to choose now. And then maintain business continuity with the ability to federate between different data sources and different data localities. So you can still continue to run your old and new environments, and then you can migrate really your data on your own terms. And then when you decommission some of the legacy systems that you see are kind of redundant that you no longer need, they really you can simplify your data platform. And then the ultimate goal, we think, the true North Star is if you simplify your data stack to say that you run the same data stack that you're running in cross-cloud, multiple environments in the cloud, or on-premises hybrid and in the cloud. So you're really dealing with one solution, and you don't have to relearn a lot of these other tools. You can really run everything using the same architecture. And then we do have a SaaS offering in the cloud as well. We can get started in minutes. Warp speed is available there, the autonomous indexing caching. And you can do choose and pick and choose clusters for your business needs, resize them, and that all can operate on the same data. If you want information for that, you can always take a look at Galaxy website, which is the name for our SaaS offering. All right. Right now, I do have a demo prepared to show you what the environment looks like. So this is the Starburst enterprise platform. So this is not the SaaS solution. This is the one that we actually deployed using Helm charts, using Kubernetes in an AWS environment. So you get a sense of how the number of worker nodes in your environment. For this particular demo, I only have 2. So it's a pretty sizable worker for Starburst. It's 32 vCPU, and then I have 2 workers that are working to bring my data back. And then there is the ability to take a look at what queries are being run, and you can filter by time, by user, and then you can take a look at what the most commonly run queries are, and who is accessing what. And then you can look at the top resource utilization by the CPU time, or by which data is being read which data is being accessed the most, which is being read the most, and which is being and what tables are being written to the most. So we definitely have a lot of control over the environment. So we are definitely very fast on top of data lake. So this is my AWS data lake using Glue as a catalog. So in this query, you can see it took about 23 seconds to return. And then if you look at what the query details for the query is doing, it's actually going through a lot of data in that time. So it analyzed about 2 billion rows. And then you can look at just what's happening under the hood. So this is the query plan that the cost-based optimizer came up with. Again, this whole query planning happens really quickly, utilizes very little resources, and then everything gets assigned to in fragments to the workers. And then they also make use of data partitioning to be really efficient with the amount of data that gets brought back. And then we can use table stats as well to be even more efficient. And then if you layer on something called warp speed on the same infrastructure, now you can get a huge performance boost if the smart indexing and automatic caching is seeing that a query is being run very often. And then it's going to start to notice that, and it'll start caching those indexes and a lot of these the columns or chunks of data that you're using on the locally attached SSD. So instead of reaching out to the network, you can actually just run these queries from the locally attached SSD. So before you got about 20 something seconds to that query, and then if you use smart indexing caching, you can get it back in a couple of seconds. So this one hasn't been running in a while, so it needs to reestablish the cache. But in a lot of cases, this result could actually return in about 1 second. Other interesting features into again, earlier we talked about the ability to federate into other data sources as well. So if you see the catalogs on the left, MongoDB, Hive, even a different cloud environment, for example, Azure. I do have a ADLS environment in Azure where I can run queries as well. And then if I run this query, it'll return in a couple of seconds as well. And then what you can see is that for this particular query, because I'm running it as an end user, I have the ability to apply RBAC rules, even though this data is coming from different data sources. And then you have the ability to do that in a cross-region format as well. So let me just go ahead and run this one where we have to bring data back from an Azure environment before I walk through what happened on the other end. So this is from Azure and the SQL Server on the AWS environment and MongoDB. So really the same query, but the data lake results are coming from the Azure environment. So as you can see here, so social security number is masked. You can still see the street, and then the date of birth is masked as well. Again, this can be done on top of a federated query, so it doesn't have to be just one single table. You can actually apply your RBAC rules at the source, and as the data gets federated, it'll apply some of these policies to the aggregated data. Now, in the cross-region environment, before where you can see that the street is completely exposed, right now the policy notice that the data is coming from Azure, so the street has been completely obfuscated. Social security number is still the same, and then the date of birth has been fully exposed now. So depending on where your data is coming from, you can apply different policies. So again, if you have trying to satisfy something like data sovereignty or GDPR, you can do that very easily. And the other neat thing is that because you can do everything in SQL, some of these more complex data pipelines no longer have to do that. No longer have to copy all the data into one location and then manipulate that data. You can just have the ability to do that on the fly. And then really, this is as a kind of a higher privileged data user. But if I switch my admin rights to be a system admin over the entire platform, you can see that I have access to every single catalog that my company uses, whether it's AWS environment, GCP environment, or Azure environment. You have complete flexibility in where your data sits, where it lives, and how you really want to query this data. Next, so a query gets run, and you can either build this query into a view or materialize view for fast access and data sharing. But at Starburst, we created something that we feel is even more compelling: the ability to add rich metadata to the views or materialize views, so it becomes easy to share and collaborate on data. So I can, from here, you can add this query that's already been run to either a new data product or existing data product. And then if I just choose a new data product, continue, and then you can basically break your data products down to business domains, to see which business domains live in, whether it's a big data environment or pharma sales or customer 360. And then you can add a full text description for what that data looks like. So what that really means is now you can make it easy to perform data sharing. So if you want to search by data, let's say customer 360, it's very easy to find the data that you need. And then you can rate the data, bookmark it. And then if you find a data set is needing more information or more data sets to be created, you can contact the owner of the data product. Every data product needs a product owner where they manage basically that data product and what it looks like, and they can answer questions to what type of story the data is trying to tell. And then if there is a need to create more data sets, you have a discussion board where that interaction can take place. And then there's tags as well, where your data can be grouped by and searched by tags. And then you can come down and really see what this data, get an overview of what the data product is doing just by running it. So this is actually running a view that's saved as a materialized view. So it's a cached data set on top of the lake. So that's how I was able to get this data set back really quickly. And you can see the masking rules can be applied at this level as well. And then if you don't want users to take a look at all data domains, again, you can really go back to the assigned roles and be able to control who has access to what type of environment. So for this particular user, even though this domain has more views, he's only able to see 2 of them. And then really, there's only 2 data product domains, that business domains that he's able to have access to, because really, it's not. This is a lot better way to manage security, because you don't really want everybody out there to see what all the other parts of the business are actually doing. And then from here, yeah, if you want to manage data sharing to the end user, you can use the built-in access control to see what the data users have access to. So for this particular user, because I don't have the privilege to assign, I can go back to the system admin mode, and I can see what the data product, what the data access controls actually look like. So if I go back to my data consumer user, sorry for scrolling here. You can see just the details of what I have access to. So just a handful of catalogs and tables, some masking rules on top of that, and role filters if need be as well. And then, as you can see, I have some data products that are assigned to that I'm able to see, but not all data products, only a handful. Okay, and that about wraps up this session. So I'll continue to monitor if we have anything in the chat, and then we do have one of our distinguished engineers that's able to answer questions there as well.